So how did those climate changes in temperature, precipitation, and remember we are not looking at humidity, even though that tends to play a very critical role as well, especially in semi-arid regions, but the model focuses, the dynamic vegetation model would consider that as well, but we are not discussing the details of humidity changes exactly, but that's okay. So looking at the response over Africa to the temperature and precipitation changes, especially including land and atmosphere temperature changes, let's add a bit more of details in terms of aerial vegetation coverage anomaly for broadleaf trees 116,000 years ago relative to 1800. Net primary productivity anomalies for broadleaf at 116,000 years ago. Aerial coverage and net primary productivity anomalies derived from the long time series that we've been simulation that we've been talking. Sorry, I have a hiccup. Somebody is remembering me. Okay. So here is again the broadleaf, but now looking at 116,000 years ago minus 1800 in terms of aerial coverage, and this is broadleaf at net primary productivity. So this is so you can have area change as well as vegetation density, which is measured now in various ways. Normalized difference vegetation index, leaf area index, and net primary productivity in terms of chlorophyll content and so on and so forth. So just because there is large area covered by vegetation in terms of leaf area or normalized difference vegetation doesn't mean it's very productive forest. It could be very thin forest in terms of availability of food, for example. Okay, just get an intuitive sense for what we are talking about. So just in terms of aerial coverage change, there was reduced area of broadleaf trees over these large parts from the front at the desert and Sahel into Central Africa, and there is a significant aerial coverage increase up to the present levels, in fact, of the broadleaf trees here. Again, remembering that they are dependent on precipitation levels in terms of which leaf morphologies do better in the given climate and who responds how when the climate changes. So in terms of net primary productivity also there is an increase along the same band, and you can see that the aerial coverage is less than the decrease in net primary productivity compared to 1800. So the forest cover would have existed, but it would have been less productive in terms of availability of let's say vegetation for not only humans but also for megafauna who were serving as resource for hominins of the time, right? So this is important to remember. Plus, in a model with the feedbacks of soil moisture, groundwater, CO2, etc., also would be very different based on how the net primary productivity is changing versus aerial coverage is changing. Okay, so those are details that are important, but here you would just want to think of them in terms of impacts on hominins, their perturbations to their existence, either bringing them together, huddling into regions where net primary productivity is growing up, or getting pushed out of existence in places where it's basically decreasing by a lot compared to the 1800s. Okay. Next, aerial vegetation coverage anomaly for needleleaf trees in the same period, 116,000 years ago. Aerial coverage and net primary productivity anomalies are again derived from this long simulation. So compared to broadleaf, again, here the broadleaf increased in this band, whereas needleleaf has been decreased by a lot, almost disappeared compared to 1800, and there is patchy distribution here. So you can see that there is a speciation happening where one species is almost completely replacing the other, but there are competitions in other places, and obviously correspondingly there is primary productivity differences, significant decreases, and that's a much larger area compared to broadleaf. So broadleaf is basically not present here, or and is similar to the current aerial coverage, but you can see there is no net primary productivity either, whereas needleleaf in a dry region would have had more distribution, and there are small perturbations to it in terms of aerial coverage difference and primary productivity difference. Aerial vegetation coverage for C4 and C3 grasses here now for the same period, so 116,000 years ago. You can see there are patchy changes in the northern part and at the front, but there are increases in aerial coverage as well as net primary productivity here, and you can see the patchiness here as well. So you have to put all those together: the grazers, browsers, megafauna, hominins, all together would have been reacting or responding to the mix of vegetations, what we would call ecosystems in terms of broadleaf, needleleaf, C3 and C4. So obviously it's easy to map these in models, but to actually use the mix to somehow infer hominin response is not going to be that easy. Okay, so this is going into precipitation anomaly in Africa at 114,000 years ago and 104,000 years ago. So just another climate signal. So we are moving progressively towards the end of towards the glacial maximum and end of the last glacial maximum into the Holocene. Precipitation, huge increase here compared to 1800 by 114,000 years ago, and then a huge flip by 104,000 years ago, with some refugia kind of situation left over here and an increase over here, but a massive increase in the northern African. So things like greening of Africa, which happened in the Holocene, can be reminiscent of these sorts of changes, where you're going from precipitation decrease compared to 1800 to a massive increase compared to 1800 in about 10,000 years. Obviously, you're going from the one MIS stage to another MIS stage in terms of stadial and interstadial. Okay, so let me leave that and come back to barren ground coverage, because now we will get out of African focus and try to look at global regions and try to see what was happening outside of Africa, and whether that also should be reflected in the dynamics we saw between Homo sapiens and Neanderthals were around at the time, and migrations into Asia that had already happened by that time. Okay, actually sapiens do not appear till much later, but whoever was there would have been dealing with these climate perturbations, vegetation changes, precipitation, water resource changes, and so on. So we'll come back and look at that in the next podcast at global scales. The model is obviously global, so it is doing vegetation changes, precipitation, temperature changes everywhere, given the orbital forcing at the top of the atmosphere. So those physical verifications, evaluations, and validations of the model are simple in terms of how top of the atmosphere radiation change over this 122,000 year simulation produces physical climate changes, and then how that is translated to vegetation changes by the dynamic vegetation model. Without talking, and we are not talking about CO2 changes, we talk a little bit about net primary production changes, which directly corresponds to CO2 changes. But as I said before, we are not talking about the feedbacks of CO2 onto the climate itself. Whether that's the first order effect or not depends on many details. Even in the IPCC models for the current climate and future projections, simulations are done with and without carbon feedback to see what are the additional impacts. For example, does global warming get accelerated greatly when you include vegetation response as well as carbon cycle feedback, remembering that now we have also carbon cycle perturbations directly related to fossil fuel changes and massive land use changes, whereas in the periods we are looking at here, they were mostly natural variability related to orbital forcing. And the key question is, how were humans responding to that in making landscape changes, and at what scale, and what that feedback would have been, whether it would have been positive, negligible, or negative, and so on. Okay.